Hey guys, so a few videos back, we learned that the half-life formula measures the amount of a substance left after it has radioactively decayed over a period of time. The half-life formula consists of the initial amount times 1/2 to the power of time over half-life, which equals final amount after a period of time. Let's find out how we apply this to certain problems in the archaeological field. Here's an example of a problem that you might one day see on any chem test or in real life. Let's read it together. The half-life for the decay of carbon-14 is 5,730 years. A piece of clothing from an archaeological dig has 21% as much as 14 carbon as a piece of modern clothing. The age of the old clothing is... Well, to solve this, we'll need to use our half-life formula, which states that the final amount is equal to the initial amount times 1/2 to the power of time divided by half-life. Okay, so let's plug in our variables. We know that the piece of clothing has 21% as much carbon-14 as a piece of new clothing. So this means that only 21% of the original clothing remains, or the carbon-14 in the original clothing remains in the sample. Basically, if we had, say, 100 atoms of carbon-14 in the old clothing, or which is our initial amount, we would basically have 21 atoms remaining. Based on this, we can plug in the other variables of the half-life equation. We know that the half-life is 5,730 years. What we are looking for is the time that it took for the radioactive substance for the clothing to lose its carbon-14 atoms. So we are looking for time, which is our X factor. So to explain this equation again, we started off with, say, 100 atoms of carbon-14 in the clothing, and we decreased it to 21 atoms over time. That's what we are trying to find out right now, the time over 5,730 years, which is our half-life. Now that we have all of our variables filled in, let's solve for this equation. 21 divided by 100 is 0.21, or 21%, which is equal to 1/2 to the power of t, or time, over 5,730 years. Let's take the log of this equation. Basically, we know that the logarithm of base 1/2 21% or 0.21 is equal to time over 5,730 years. Now let's go ahead and multiply 5,730 and 30 to each side of the equation. What we get is approximately 12,900 years, which is the answer to this problem. Basically speaking, a sample of clothing had 100 carbon atoms, carbon-14 atoms, when it was made. Then, after 12,900 years, it decreased down to 21 atoms of carbon-14 because the carbon-14 was radioactive. And that's it.